Welcome, everyone. We're very excited to have Russ Patterson with us, a veteran game developer who spent decades building and scaling games and player systems at companies like Sony, EA, Zynga, and Jam City. Russ brings a rare practical perspective on player behavior and game design. And with that, the mic is all yours, sir. Let's get into it.
All right, thanks. Really excited to be here. As I said, I've been making games for a long time, and today I want to show you something very practical you can use with AI. Simple on-device models that you can build yourself that help predict what players are going to do next. So when people hear about AI, they tend to imagine something mysterious or out of reach, and I want to show today is the opposite, that these models can be really small, understandable, and very buildable by game developers. Most of the time when we talk about AI, we mean giant models, LLMs and diffusion models, and they feel like black boxes that are owned by another team. We're just the users of them. But that framing is what stops a lot of game teams from engaging with this at all. So to reframe AI, at the end of the day, a model's just a function. Inputs go in, outputs come out. The only thing it's doing differently from a normal function is that it adjusts itself when it gets things wrong. All models do basically the same job. Given some inputs, they try to predict an output. They learn from examples, and over time, they get less wrong. And a big point I want to make is you don't need a team to do this. The models I'm talking about are small, fast, and focused. You can build a model, one model that solves one problem really well for your game. Even neural models here that I'm talking about are on the order of 40 to 60 kilobytes on disk. So about the size of a small texture. And they run comfortably in under a millisecond, even on a Samsung A14 $200 device. So this matters for games because games are, basically decision machines. Players are constantly making choices, and those choices happen in states. If you can understand the state a player is in, you can start to predict what they're likely to do next. To make this concrete, let's talk about player states. A player might have just one, they just failed, they're stuck in a level, or they're browsing the UI. At any moment, they're in one state, and from that state, they have probabilities of moving to other states. And one simple tool for predicting what happens next is a Markov chain. Certainly not your only choice, but that's what we're going to dive into today. And all it does is model the probability of moving from one state to another. So each state is a node in your graph, and the transitions are the edges, and the weights are just probabilities learned from your data. So we're just counting what happens next. It's that simple. You can kind of see from the diagram there, I tried to show how I like to visualize this as every state or node has a series of probabilities of its transitioning to another node. And you can build these very simply. You define your states, you count your transitions in your data, and then you normalize them into probabilities. So at the end of the day, it's really just a table. That's how simple it is. And what this gives you is foresight instead of guessing. You can estimate, you can use this to start estimating churn risk, understand whether a player is likely to retry or quit, decide when hints might help, or whether a session's likely to continue. And it can also inform when an offer might be helpful for a player versus just noise and annoying. So everything that I've talked about so far is just the whole population level. So imagine if you have a week's worth of player data and you train your model, your Markov chain on this, you get probabilities for the whole based on the whole user set. But you can, that's the starting point. But the next step is personalization, where you have basically each player starts off with that base set of numbers from the population, and then as they play, you're adjusting that model based on how they're using the game, right? Because every player is unique. And it's the same structure, it's just tuned to the individual. And so, how small is this? You're saying, well, I'm going to have one for every player. Well, first of all, it's just on their device where you need their custom model if you want. And a concrete example, even a 24 state markup chain is just a 24 by 24 table. It's a few hundred numbers, kilobytes, not megabytes. And one important thing here that I want to talk about is that I'm not saying like AI is going to decide how to run your game. This is about providing data for your team, your designers and product team to decide what to do with the numbers. The models don't make design decisions. They just generate ranking scores and confidence signals. Humans decide what to do with that information. So the takeaway is stop designing blind, build small, fast models that are specific to your game and your players, and use them to predict behavior and keep your designers and product team in control. And this doesn't require a big team or big models, just a shift in how we think. And of course, the Markov chains are just a start. You can start using that as a starting point to feed into other neural models that are, again, very small and have an ensemble of models on device that are, you know, each contributing their weights and helping you decide what the player's behavior is going to be next. So thanks. That's my lightning talk and happy to take questions.
Russ, thank you so much. Looking forward to getting into this. And with that, we usually just use the raise hands tool in Zoom, but who has the first question?
Actually, I
Uh,
have a question, if I may.
go for it,
Um,
Ian.
Thank you, Russ. Actually, this is great stuff. I love it. One of the challenges I see when it comes to implementing AI models in general, related to player behavior, as you pointed out, like state is critical. That's essentially your starting point, your input to your model. But where I see is the team's getting kind of paralyzed at defining like what state is relevant, because generally speaking, creating or tracking state, like all of that is engineering effort. I mean, things like just one are pretty simple, and some of the things are just you kind of get from the environment, but then it's basically you start getting into feature design, like the data features, and it's like kind of I see teams getting stuck on that phase, and I'm just kind of wondering what advice you have when it comes to like state tracking and how you approach that, so that you're not like spending a ton of time trying to create a bunch of you know uh, machine learning features that turn out to be not relevant.
Yeah, so player state, of course, your game's got to really have a strong sense of state. You're going to have all kinds of bugs. And I would say, just use your intuition to see what states might be relevant for the decisions, like work backward from the decision you want to learn about the player and work backward for what states might be relevant. And I haven't put a lot of time into it, but I'm sure there's a way to, if you were tracking, like, is this too many states, you could uh, you know, use some kind of a k-means analysis and a primary component analysis to see what states have the most impact. Um, but again, having a few too many may not really hurt you because in this case, it's not much data at all. It's a stack of floats.
Okay, so basically your advice is work backwards
Yeah,
and try stuff. Yeah. Okay. Thank you.
sure.
Who has the next question? Yeah, okay. Olga, please, all yours.
Yeah, I have. Nice to meet you too once more. Um, I have a question actually. First of all, Russ, thanks a lot about this. And I'm from Zeptalab, and we right now introduce a lot of AI stuff. But I'm an artist, and I'm not super familiar with what you are talking about right now. That's why I would like to ask you about a certain question. Do you have, a kind of pipeline from this task, initial one. Yeah, we have a certain task that we need to solve. Then we decide how exactly we train our model. Then we implement this, and then we have certain results. If you have such an example, I would be super grateful if you share it.
Sure. I think example would be you're trying to predict churn, right? Is a player going to retain or churn, right, in the first 7 days? And what you would want to do is, if you have training data and you have data, players that did churn or retained, and then you can train even a simple MLP model on what are those, what events happened in this big chain of events of a week's worth of player data, up to the point where they retained at the end of 7 days, they came back for day 8, or, they turned out. And then you could deploy that model, and it's going to help you determine if they're, heading towards that, and also churn because the game is too hard for them and they're frustrated, or it's too easy and they're bored. And so you can see those patterns for, like, how long are they taking level, how many fails, how many power-ups are they using, and so you get these signals, and you can use your intuition to figure out what signals you should be looking for, right? And you can do the primary component analysis to verify that. And then if you know they're churning because the game's too hard, you can on the fly simplify those levels, give them more moves or whatever that knob is that you can turn there, easier words to pick, whatever that is, or make it more difficult, more challenging. Offer them levels that are more challenging on your difficulty curve. And then also a big part of that is then really understanding how difficult are your levels. And so that's another model that you can do offline to train, look at all your user data and all your model data, and then you figure out a difficulty score, 0 to 1 for those levels. And then you get your source data, your JSON file that describes the level or whatever. And then you train a model to learn, like, from this source data, how difficult will my level be? So then you can make a tool for your designers that say, when they're just, concepting a level, it gives them a difficulty score based on all this, data you learn from your users.
Understood. Thanks a lot.
Great. I have a question, Russ. So yeah, I've been also looking at localized kind of like models to utilize the GPU that you have on board, rather than going out. Everybody immediately goes to, I need to build up an AWS cluster to run these things. So many models can be run locally with the efficiency you already have on board. And it really, and I love your point. The responsiveness of those models is the most important part of the game. So great. I've been using those models as a design intent verifier. So I'm building design intent from design documents using a RAG style model, and then measuring player data against design intent. And the biggest way I've been doing this is through Fatui. So everybody tries to design a Fatui for everybody, a first time user experience for everybody. Whereas actually different players have different ways and which different things they need. They might need more training in combat. They might need training in navigation. So an adaptive Fatui is how I've been using these models for localized player data against a design intent Fatui. Have you had any experience on that side? Yeah, like with those kind of real-time player adaptive models that are normally static in gaming.
Yes, Phil and I actually worked on some of this together, basically figuring out how to make adaptive gameplay to make the game slightly easier or harder. But the Fatui example, we have not dove into that. And that's really interesting. Yeah. And then perfect example, because, right, everyone's different. They learn different. They need help with different things, and seeing how they play and what they need help with, that's a great idea.
Yeah, we see especially in free to play, we see people churning for TUI because they hate being told how to do things. And so if you can make that for TUI adaptive on their experience, and measure the data as it comes in, you can see how quickly you can even abandon a Fatui for an experience play.
Yeah, or insert one,
Yeah,
between level 3 and 4 because they're
absolutely.
clearly struggling with some
Yeah, yeah,
navigation.
and that's the thing I Russ, I like, this adaptive gameplay. But hey, you're having trouble with combat. Why don't I insert an event that doesn't look like a training event, but it's in a different event on your route, and then it's suddenly I'm training you up in sword play, but it's not called a fertility.
Exactly. And that's what I think we're going to games or apps that learn what kind of game you want them to be the more you play with them.
Yeah,
And
and that's why,
everybody,
yeah.
yeah, gets a unique experience, and we're not just using AI to make content faster, we're
Yeah.
using it to make better games.
Absolutely. But I think the extracting the design intent is the other side of that problem. Yeah, and I'm using a RAG style LLM model to extract design intent because what getting someone to write like a script I'm measuring against or write what the output should be from a designer, that's sometimes a difficult task and a very engineering specific task. How about I build something that's like RAG-like, takes their design documents, takes their design intent, asks them questions like a standard large language model, and then creates the design intent I measure the player against.
Yeah, that sounds great.
Cool, cool. Anyway, thanks, Ross.
Thanks.
Hi into the round. Thanks for the lightning talk. I mean, I have been looking into adaptive game behaviors for quite some years now. And as mentioned previously, a lot of the challenges come with actually understanding what to design for with this knowledge or with these models. And a lot of the cases I've seen people try optimize systems that maybe weren't the right ones to begin with. So if you optimize something that's already not doing a good job, then you usually can't generate big wins with it. And so the fundamental systems and how well the gameplay works and how well the onboarding systems work in general has always been the hardest part of the work. And then these kind of adjustments to your experience probably are like more like the getting it from 80 to 100% rather than, this one is fixing the main problem. So I wonder, have you seen like a use case where this really made a fundamental change in how the game performed? Like, has this been something that worked for optimization in projects that you tested, or was this a game changer in any of these applications?
So the actual real world experiences have been more optimizations. Like you've got a game and people are liking it and the numbers are good, but we're trying to improve them, right? It's like especially soft launch period. And that's tricky because you don't have a lot of data in that period. And data is something you need, absolutely. So and yeah, that's kind of my nightmare is that somebody hires me on a consulting gig to help them fix their game that just isn't any fun in the first place. And what I'm gonna do, tell them or just, try and help them. Um, but I think that if you focus, use it to make major fundamental design issues by, basically using data, maybe more offline ML studies to prove that, hey, this is where it's not working and why. Um, uh, but yeah, I guess that's kind of in a way a golden thing of like building AI models that would tell you if this game is going to be attractive to players or not, before you release it. That would be amazing. And I think it could be done, right? We know what games work and what games don't. We could certainly, we have training data if you could get your hands on it.
That's a good point. Yeah. I mean, um, still, why something isn't working, I guess sometimes I have seen games majorly improve by making small twists. Like I've also seen big pivots that made the game better, but sometimes it's just this one thing that nobody sees because you're so like in the weeds
Yeah, I
right?
think a lot of times it's that, and then people just throw the whole thing out and redesign everything because they got some bad, player scores when it was full of bugs. And it's like, well, we fixed the bugs and it wasn't a terrible experience with all kinds of things not working the way you expect. Maybe they'd like it. But, instead of that, they redesign everything.
So yeah, I guess the AI can help you define those signals and like you can try to detect these more data-driven patterns, but ultimately it's about like if you know what really changes the game for the player's experience and like makes
Right.
it better, that really is the power in applying then even any kind of AI,
Yeah,
if it's
like
local.
offlines analysis like k-means where you group players based on data, right? And you see these are the players that are engaged, or these are the players think it's too hard or too easy. And then doing, a primary component analysis. So you see what factors are really pushing those directions, and that's what you can attack. That's telling you these are the important things to fix.
John, I felt like you had a question.
Yeah, I'm looking for the raise hand button, and every time I open
Yeah.
Zoom, it
I
changes.
I
It's
sensed it. So much for
I
AI.
You're
Go
like
for it.
waiting for it, really. Uh, do you find that people have the same resistance to using Markov chains and simple models that exist already compared to the toxic reaction that the game community has to AI and LLM technology? Or do you find that people are like, yeah, this is tried and true. I can use this and I'm not going to get my award of the year taken away?
I that reaction, at least in the consulting gigs and teams I've worked with, I haven't really noticed that there because I think at that point they want to try this, right? And the CEO
Hmm.
wants to try it, so everyone's like on board. Um, and I think it would be if they understood it, if you get them past the point of like, hey, this is just a small, like even a markup chain, it's like it's a table. Don't call it an
Yeah,
AI
yeah,
model,
right.
right? Um,
Hmm.
and I think, uh, if we go back in the game industry from 16-bit to 32-bit era, when we went from 2D games to
Yeah, yeah,
3D games, there are a lot of game developers, like that Phil and I work with, that didn't learn C and they didn't learn 3D, and but they
yeah.
knew assembler great and they knew all these tricks, and they couldn't get jobs, right? Because it was like, hey, how about we hire,
Hmm.
so and so, and they're like, oh, well, they don't know C, and they're not going to learn it. So I think that's as we see the industry changing, we have to see this as a huge shift, bigger than 2D to 3D, bigger than offline to online.
Yeah.
And as game developers, if we want to keep being game developers in the next 3 to 5 years, we need to embrace this and get good at it, using it, right? Because if you get better at figuring out what your players are doing and you retain more users, your LTV goes up, you spend more on
Yeah.
ads, ad inventory goes up for, down for everybody else, prices go up for everybody else. And
Yeah.
that's the way the business is going to change. So I would
Hmm.
do everything you could to convince them that this is not the time to be a Luddite and dig your heels in on what worked for you before.
That's literally the approach I take in a lot of conversations with people. And I post a lot about AI and the future of games on LinkedIn and have a lot of conversations there. And I literally have to tell people to go look up a Luddite and tell them it's like, look, this is a transformative shift. And the big concern I have for people is the people who are fighting against it the hardest. They're going to be the first people with the green open to work banners, right? It's like, look, these
Yeah.
tools are here. They're here to stay. And one of the things one of the reasons, and thank you for this talk, I was very excited about it is like, what are some of the things that we could do to start telling people everything is going to be okay, right? This is just another technology tool shift. And these
Right.
things are going to be meaningful because, mobile games and you have other types of games where people generally don't care, but the hardcore gamer constituent and even a couple of my own kids and a lot of people who work in the industry have this incredibly strong negative reaction to these things. And it's good to see that there's comparable technologies and yes, and it's even interesting to see that, there's things out there that you can show people. It's like, look, this is basically the same thing. Why doesn't this get you hopping mad? Right. So
Yeah, I usually like to say, like when people talk about the cotton gin or the printing press, They don't talk
Yeah.
about the jobs it destroyed.
Right.
Yeah.
And the new jobs, an order of magnitude more
Right,
that got
right.
created, right?
Both of them were
Yeah,
huge
I know.
advances, but at the time, it was very disruptive, and lots of people
Mhm.
didn't have jobs because there was a better way to do it.
Yeah.
Yes.
Yeah.
Cool.
Just
I
to
guess
add to that.
more of, sorry, go ahead.
Yeah, so just to add to that, guys, like I always like to refer back to a technology that improved games or changed in games. I'm old enough to remember that when everybody used to hanky animation, hand animate, everything was done, and then came along mocap, and mocap was like,
Yeah.
oh my God, it's a huge accelerator to the way I produce animations. No one cares about mocap anymore. It's part of actually creating games, especially large AAA games. It's part of that accelerated animation process. We should see these AI models as acceleration models to improve the craft we already have. Like, just like there, it's an acceleration model. And if you don't want to use an acceleration model, then you're going to be going back, hilling stones with chisels. I mean, if you still want to use those old tools, fine, that's great, but your output will be affected. So
I think it will be good to get the three of you to do a panel talk, or just ask each
Sure.
other questions.
yeah.
You're clearly passionate about this, and John, to your point, the
Yeah.
first step towards doing that is to start talking about it, putting it out there. Hey,
Yeah.
this is what my opinion is, and to sort of take that extreme. So
Yeah.
I'm going to bug you to help facilitate, make that happen too. So get Russ, John, and Mark. One of them can ask questions, two of them can answer, and then we can flip this, have some fun with that. But it has to be about what John said, like what can we do or say to get everyone to
Yeah.
calm down about
Absolutely.
what a disaster AI is. And with
Absolutely.
that, since I have promised you all that I will always end this on time, I'm going to try and wrap this up. Thank you all very much. I hate it. You all just get warmed up
Yeah.
in the last minute, and then I have to come in and say, okay, I'm going to close this down. But it is what I promised.
That's
Okay,
great.
see you all next time.
Yep.
Thank
Bye.
you.
Thank you so much for coming.
Thanks, everybody.
Thank you. Bye bye. Thank you, Russ.
Bye-bye.
Great talk.
Thanks.